Welcome to another video in the Higher GCSE Basic Skills section. This one is on simplifying surds. So I'll leave you to pause and read the theory about what a surd is, and then we'll go on to simplifying surds now. So surds can be simplified if there's a square number factor of the number inside the root. So the following are examples. So the square root of 20 is the square root of 4 times 5. 4 being the square number, the highest square number that is a factor of 20. We can now split this into the square root of 4 times the square root of 5. And this will further simplify because the square root of 4 is 2. So this will become 2 root 5. The square root of 75, we're going to look for the highest square number that's in 75, and this is 25. 25 times 3. Again, split these. Becomes the square root of 25 times the square root of 3. The square root of 25 is 5, so this becomes 5 root 3. The square root of 48. Now 4 is a factor, but 16 is the highest factor. That is a square number. So this is 16 times 3, which can be split into the square root of 16 times the square root of 3. The square root of 16 is 4, so this becomes 4 root 3. So surds can be multiplied by whole numbers or other surds. So examples include 2 times root 5, and this is just simply 2 root 5. The square root of 3 times the square root of 3, so root 3 times root 3, which is root 3 squared. We're just undoing the square root here, so this becomes the original number, 3. The square root of 5 times the square root of 7 is the square root of 5 times 7, which is the square root of 35. And the square root of 5 cubed is the square root of 5 times the square root of 5 times the square root of 5. These two would multiply together to give us 5, because that's root 5 squared. So this would give me 5 root 5. And surds can be added or subtracted. We treat surds just like algebraic variables when we're adding or subtracting. So 4 root 5 plus 6 root 5 minus 3 root 5 becomes 4 plus 6 minus 3. So 4 plus 6 is 10, minus 3 is 7. 7 root 5. As we can see, there's a root 5 in common. So expanding brackets and simplifying, a surd can be mixed with constants to make an expression inside a bracket, and this could be multiplied by another expression inside another bracket, as follows. So 2 plus root 5 multiplied by 3 minus root 2 becomes, and we're going to use FOIL here, so 2 times 3 is 6. 2 times minus root 2 becomes minus 2 root 2. Then root 5 times 3 becomes plus 3 root 5. And root 5 times minus root 2 becomes minus root 10. None of these can be further simplified. That surd at the end, minus root 10, that can't be simplified as there's no square number factor of 10. Therefore, we leave it as that is. And here are some questions with worked solutions. I suggest you pause the video now to go through these yourself, and I'll provide the answers. So pause the video now. And welcome back, and here are the answers. The square root of 8 is the same as the square root of 4 times 2, which is the square root of 4 times the square root of 2, which is 2 root 2. 2 root 50 becomes 2 times the square root of 25 times 2, which is 2 root 25 times root 2. Root 25 is 5, so 2 times 5 is 10, so it becomes 10 root 2. 3 times the square root of 200. Well, 100 is the highest square number in 200, so this becomes 3 times 100 times 2, which becomes 3 root 100 root 2 times root 2. Root 100 is 10, so 3 times 10 is 30. That's 30 root 2. 7 times the square root of 98. Now, the square number that goes into 98, we have to kind of get used to writing our square numbers out. So obviously 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, etc., etc. Root 98. Obviously, this is not a square number in itself, so we can't take the square root here, but a square number that goes into it is 49. So this we can do is 7 square root 49 times 2. This is 2 times that. So again, splitting these up is 7 root 49 times root 2. 7 that equals 7 times 7, which is 49 root 2. The square root of 31 all squared is 31, and the square root of 27 is the square root of 9 times 3, which when we split is root 9 times root 3, which is 3 root 3. Just to prove that not all surds are root 2. I appreciate there are lots of root 2's there. So question 2 is about simplifying the following expressions. Expand the brackets and simplify where necessary, and write your answers in the form a plus b root c. 8 minus 9 is minus 1, plus 6 is 5, so this becomes 5 root 2. Root 3 plus 15 root 3, that is 16 root 3, minus 9 root 3 is 7 root 3. And then expanding these double brackets, we get 7 times 2, which would be 14. 7 times plus 3 root 2 would be plus 21 root 2. Minus 2 times root 2 would be minus 2 root 2. And minus root 2 times 3 root 2 would be minus 3 root 2 root 2. Now root 2 times root 2 will become 2, so this will become minus 6. So I'm going to rewrite this as 14 minus 6 plus 21 root 2 minus 2 root 2 will become 19 root 2. And the final simplification, 14 minus 6 is 8 plus 19 root 2. Well, thank you for watching. Please feel free to leave a comment to ask for videos on any specific topics you wish to see. And if you enjoyed this content and want to see more, then please subscribe.